Ever wondered how network traffic is analyzed? In the vast web of the digital world, network traffic is like the lifeblood flowing through the veins of the internet. Understanding this traffic is crucial to maintaining the health of any network. Enter the realm of network protocol analyzers, the stethoscopes of the digital world that help us examine the heartbeat of network traffic. One such powerful tool is Wireshark. It's akin to having a magnifying glass that lets you inspect the intricate details of network traffic. From capturing and browsing traffic on a live network to examining data from a capture file on disk, Wireshark opens up a world of possibilities. It reveals the source and destination addresses, the protocols used, and even the contents of individual packets. Whether it's troubleshooting network problems, analyzing security issues, or trying to understand how a particular application or protocol works, Wireshark is the go-to tool. So, ready to dive into the world of network traffic analysis with Wireshark? Stick around. What exactly is Wireshark, you ask? Well, imagine having a magnifying glass that lets you peer into the intricate world of network traffic. Wireshark, in simplest terms, is that magnifying glass. It's a network protocol analyzer, a tool that captures and allows interactive browsing of traffic on a computer network. Ever wondered what happens when you click a link or send an email? Wireshark is the tool that can answer those questions. It lets you examine data from a live network or from a capture file on disk, displaying details like source and destination addresses, protocols utilized, and even the contents of individual packets. This powerful tool is essentially used to troubleshoot network problems, analyze security issues, and understand the workings of specific applications or protocols. It's a vital instrument in the toolkit of IT professionals around the globe. Wireshark, in essence, is your magnifying glass into the complex world of network traffic. Now that you know what Wireshark is, let's get it set up. The first step is to get Wireshark installed on your system. You can visit the Wireshark website and download the version that suits your operating system. Whether you're on Windows, Mac, or Linux, there's a version for you. After downloading, run the installer and follow the prompts. It's a straightforward process, just like installing any other software. Once the installation process is complete, launch Wireshark. You'll be greeted by the main screen. Here, you'll see a list of network interfaces that your system has. These could be your Wi-Fi, Ethernet, or even virtual interfaces if you have any. Now, you might be wondering, which interface should I choose? The answer depends on where the traffic you want to capture is going. If you're connected to the internet via Wi-Fi, select your Wi-Fi interface. If you're wired in, choose your Ethernet interface. If you're unsure, you can always start capturing on all interfaces and narrow it down later. To start capturing, simply click on the name of the interface. But wait, before you do that, let's talk about a couple of settings you might want to tweak. First, you'll see an option for Capture Filter. This allows you to specify what kind of traffic you want to capture. For instance, you could set it to only capture HTTP traffic or only traffic to and from a specific IP address. If you're just starting out, you might want to leave this blank to capture all traffic. Next, there's the Capture Options button. Clicking on this will open a window where you can adjust various settings, like the maximum file size for your capture or whether to automatically start a new file after a certain amount of time. Again, if you're a beginner, the default settings are probably fine. Once you've got everything set up to your liking, go ahead and click the Start button to begin capturing packets. Once you've started, you'll see packets start to fill up the main screen. Each packet will show you information about its source and destination, the protocol used, and more. And voila! You've successfully set up Wireshark and are ready to capture some packets. So, you've set up Wireshark. What's next? Capturing packets, of course. First order of business is to select the network interface you want to capture traffic from. This is done in the main interface, where you'll find a list of available network interfaces. Select the one that matches your needs, whether it's a wired connection, wireless, or even a virtual network interface. Once you've made your selection, it's time to hit the Start button. The moment you do this, Wireshark will begin capturing packets flowing through that network interface. You'll see a flurry of packets start to populate the screen in real time, each represented by an individual line. This is the raw data of your network traffic. And it's all happening right before your eyes. Each line or packet carries a wealth of information. The first things you'll notice are the source and destination addresses. These are the IP addresses where the packet originated from and where it's headed to. These can be quite useful in understanding network flow and identifying potential issues. Next, you'll see the protocol used for that particular packet. Protocols are basically the rules that govern how data is sent and received over a network. You might see familiar ones like HTTP for web traffic or FTP for file transfers, but don't be surprised if you encounter a few you've never heard of. There are hundreds of protocols out there, each serving a specific purpose. Now, you're not just limited to viewing these details. Wireshark's power lies in its ability to let you interactively browse and filter this traffic. For instance, if you want to see only HTTP traffic, you can set up a filter to do just that. This allows you to focus on specific types of traffic, making it easier to troubleshoot problems or understand how a certain application is communicating with the network. Just like that, you've captured your first packets. But what do you do with them? Capturing packets is only half the battle. Now comes the analysis. Once you have your packets captured, Wireshark steps into its role as an analyzer. This is where the software truly shines. It's equipped with powerful filtering and display features that let you dive deep into the details of your network traffic. But how do these features work? Let's break it down. Wireshark offers a variety of filters that help you zero in on the details that matter most. For instance, you can filter by IP address to view all traffic from a specific source or destination. You can also filter by protocol to see how often a particular protocol is being used. Moreover, you can even filter by packet content. That's right, if you're looking for a specific string of text or a certain type of data, Wireshark can help you find it. But filtering is just the beginning. Once you've isolated the packets you're interested in, Wireshark's display features allow you to delve deeper. Each packet is broken down into layers, showing you everything from the source and destination addresses to the individual bits of data. This level of detail can be incredibly useful for troubleshooting network problems. You can identify patterns, spot anomalies, and diagnose issues. For instance, let's say you're experiencing slow network speeds. Wireshark can help you pinpoint whether the issue is due to network congestion, a faulty device, or perhaps a rogue application consuming more than its fair share of bandwidth. But it's not only about troubleshooting. Understanding how applications behave on your network can be equally insightful. You can observe how an application interacts with the network, which protocols it uses, and how much data it sends and receives. This knowledge can help you optimize your network, ensure security, and even improve application performance. And that's how you analyze network traffic with Wireshark. But what about when you're done? Done with your analysis? Don't let that data go to waste. It's time to save and share your captures, and Wireshark makes this process a breeze. Let's start with saving your captures. After you've completed your analysis and perhaps even discovered some interesting traffic patterns, you can save this data for later use. To do this, simply navigate to the File menu and select Save. A dialog box will appear where you can choose the location and name for your capture file. Remember, Wireshark saves these files in a PCAP format, which is a standard format for network data that can be opened by most network analysis tools. But what if you want to share your findings with your team or need to collaborate on a network issue? Well, Wireshark has got you covered there too. Once you've saved your capture file, you can easily share it with others. Just attach the PCAP file to an email or upload it to a shared network drive or cloud storage service. Your colleagues can then download the file and open it in their own copy of Wireshark for further analysis. Bear in mind, however, that network captures can contain sensitive information, including passwords and other confidential data. So before you share a capture, it's always a good idea to sanitize it first. Wireshark provides tools to remove or obscure such information, ensuring you can share your captures safely and responsibly. One last tip. If you're working on a particularly complex issue, you might want to save your Wireshark settings along with your capture. This includes your display filters and color coding rules. To do this, You just need to choose Save As from the File menu and select the PSML format. This will save a session file that contains both your capture and your configuration settings. And there you have it, from setup to sharing. That's how you use Wireshark to analyze network traffic.